So we are here now. Okay, one more second. Okay. So on PE2, let us see how we are able to see the MPLS. First, let us verify the connectivity. Okay, between the CE2 and the PE2, what we are running, let us verify this connectivity so that we know what exactly is happening between these two devices. Right? So here, let's go to the CE2. CE2 has show OSPF neighbor. Currently, there is no OSPF neighbor, so I've shut the Xia. So what you are going to see now is show BGP all VRF, let us say. So this is the IBGP session which you are running between your CE and the PE. So if you want to verify that one here, show BGP VRF, VRF1, IPv4 unicast. Summary should be able to verify. You can see that one. So eBGP between the PEs are established. Okay, and let us check the IGP between these PEs, right? The LSR. How do we check that one? The IGP, which we said we have to run the OSPF. So if you see show OSPF neighbor, because here I have a connectivity between only one link, that is 1/1/15 is connected to 1/1/47. That's where you see this, right? So this is the neighbor. So 1/1/15. The IP is 30. Okay, I think I made a mistake here, giving 60 here. So that's okay. So you can see this is reaching the PE3. And let's go to the PE3 and verify whether I have the same IGP. Show IP OSPF neighbor. Yes, I can see this is the interface towards the PE2. And I have a P5 which is connected. Similarly, you can check all the interfaces, right? So we can check P5. Show IP OSPF neighbor. So you can see here, and this is not new. This is there from day one, but I'm just making sure you're running the IGP proper. This is the first step you have to do. And you can see here, even between the P1 and the CE1, eBGP is established, and we are going to make sure the OSPF neighbor between the P1 and the P4 is established. So IGP is up, and I also have eBGP running. Let us check whether I have the IBGP running between the PEs. Show BGP VPN v4 unicast, right? And we should be able to see IBGP also running perfectly fine. So now what we should do is, let us see show MPLS LDP neighbors. So because I have only one IGP connected to P4, you are seeing exactly the same thing. So now if you look at show MPLS forwarding, I have some BGP VPN v4 routes also getting learned on the P1. You can see the service label as 16. If you go and check here, who is distributing this 16, show MPLS forwarding, you can see here the 16 is coming from all the way from here. He is the one who is distributing the service label. Okay. So the service label is reached here, and to get there, the next stop addresses, you can see here, to get to that next stop address is 222. For 222, you have to, the incoming label is 60. That means all incoming labels are generated by self, but the outgoing label is the label which is given by the PE, the peer node, the LDP neighbor. Show MPLS LDP neighbor, if you look at it, the 444 is the LDP neighbor, and it has given 38. Let's verify that one, whether it is giving the 38 or not. The command for that one is exactly same, show MPLS forwarding. And you can see here for 38 is given by the incoming label, you can see here 222 was generated by this guy. The incoming label is generated by the self. Outgoing label is given by the peer. For 222 now, in order to reach, I have to go to 36 and the next stop is 7102, which is on a 1/1/9, which is nothing but the P5. If I go and look at the P5, I should be able to see a 36 for same show MPLS forwarding. If you look at it here, the 36 is the label which is generated by the P5 and 41 is the label given by the P3. And if you go to the P3, show MPLS forwarding, and you can see very clearly that is given by the P3, right? It's for 22. You can see here it is giving the explicit null. Who is giving the explicit null? The P5, because it is reaching 222. As you are seeing, this is a static, that is the exit binding, which is distributing the explicit null to the P3. So we saw this one. Now let us see, can I ping the other end of the CE? Because we have all the connectivity, we should be able to ping, right? So let us see. First, let us check whether the 2202 is the connected interface there. If you look at here to show running config interface 1/1/24, you can see 2202 is the interface IP address. So let us ping that one from the CE1. You are able to ping, and let us see what is happening on the P5 device. DAG utility, because it's a ping, we should be able to see the T-shark on the box as ICMP. Hope you are able to see the screen. Let us check 1 minute. Hope the ping was expired already. Let us send repeat one. Let's only do one and we'll stop it. Let's check the ICMP here. These are all hello packets, so we should not be worried about that. We are interested in the ICMP. Or we'll do one thing. We'll just keep sending and then stop it. You can see here now the ICMP, you can see here ICMP messages are flowing, and you can see the label how they get distributed, which we were talking about on the P5 to distribute to reach 22234. The same labels are getting distributed. But remember, the service label which is given is never going to change until unless it reaches the PE, because that's the intent, because it has to pass it to the right VRF. You need to have the service label constantly carried across the LSR, right? So that's what you are seeing here. With this, now what we will do is we'll go and start some IXIA. That means we'll have a number of customer routes coming in from the CEs, and we will see whether they get redistributed and then learn on the overall VPN v4 path. Let me start this protocol. Let me see on the CEs if the OSPF is established. What OSPF I'm talking about is the OSPF which I'm running between the CE and the customer site. That is nothing but the IXIA port. Here I'm using the VLAN 30. That is the SVI I'm using here between the CE1 and the IXIA port. So let me go to the CE1 and see whether the OSPF is up. Show OSPF neighbor. Looks like it is up. Let me see on the CE2 also. Show IP OSPF neighbor. Okay, so that means I should be able to see show IP route. Routes are here. Okay, I see some routes here. So whatever you see 101 are the routes coming all the way from the CE1 side. Whatever you see 200 are the routes coming from CE2 to IXIA. That means it is just connected. You can see here OSPF, you can clearly see here. And this is learned via egress interface 1/1/24. Let us see where is 1/1/24 is connected to. Oh, it is connected towards the PE2. Let us check the PE2. What's happening on the PE2 now? Show IP route, right? And VRF1. So let's check this one. Very good. So you can see here, these 200 routes are coming directly from the eBGP. But these 101 routes we never had earlier are now learned because we started DXCR now. So are coming all the way from the CE1 because of the VPN v4. Okay. Now let's run some traffic also and see how the label swap happens. One side will run a traffic. Let's go here. I'm going to send 1 packet per second. So that way it is going to be clean. Let me send it from CE2 to CE1 side. Okay. That means 200 is the source and it will reach the 101 kind of a network. Okay. That is the prefix which we are talking about. Okay. There is no loss. Perfect. So let's go here and let's look at the capture again. As I said, we should see some source. Okay, we directly saw that one. Let me stop it. Stop it, stop it, stop it. Cool. Let's go and look at this one. I just saw we are interested in data traffic, which we are sending, not hellos. So that's where I'm going up, up, up. You can see here, this is the data which is going. And as I said, the source is from 200 side and destination is towards the 101. And you can see here, it is on the MPLS header. This is your MPLS transport label, and this is your VPN v4 service label. Okay. If I change, Daryl was talking about the QoS, we can even play around the QoS. We can just change the toss bit, and same if it, because it's a uniform, we have the EXP 3-bit, it will carry exactly the same QoS parameter across the LSRs. Okay. So let me go back and see how you can do the multicast. I don't know which screen you're seeing for. Give me 1 second. Yeah. Now to do the multicast, because we don't support, we have a workaround. What is the workaround? Let's get to that slide. The workaround is this one. You need to form a VXLAN tunnel between the CEs and you can send your multicast traffic. Right? That way, the only requirement is your CE should be able to support your VXLAN. So let me go back and see if my VXLAN is up on my device. Okay, here it is. So show interface VXLAN. Do I have the configuration first of all? VXLAN vtab. Oh, looks like it is good. So you can see here it is up and perfectly fine. VXLAN VNI. I can even start the multicast and show you guys how you can do the multicast. It's basically once this is not new. This is your old feature, but just this is the current workaround we have. So if you look at the show running config EVPN. Yes, everything is perfect. So we can start the multicast traffic also, and we can see on the stats. That is also possible. Okay, now you can see there is no drops on the XCR side. Let's let it run. You can see there is no drops. It's perfectly running fine. And what you have done is you have formed the VXLAN tunnel between the CEs. With that, we have done the L3 VPN. We saw IBGP between the peers. We also saw the OSPF configuration for LDP, which is very important and that is only supported. And we also saw CE to P IBGP session and how the routes are getting exchanged with the L3 VPN setup. And also we saw the multicast. With this, let me stop here